Alrighty, so welcome back to the calculator overview video because you need to know how to do these, but mostly in the calculator. So we're going to go through each procedure and I'm going to show you how you pull the expected, how you get the test statistic, p-value, all of that good stuff. So let's start with goodness of fit. Again, we're looking at one single variable in one single population. So let's go to the example here. And when you do goodness of fit, this one's going to look slightly different than homogeneity or independence. So here we have our observed list and our expected list. So when you open up your calculator, instead of going to calculate, you're actually going to go create a new document. And you're going to go here to add list and spreadsheet. All right, so in column 1, we are going to do our observed values. And in column 2, we're going to do our expected values. And we're actually going to go vertically instead of horizontally. So if I'm using this example from the notes here, my observed values would be something like 54, 18, 13, 15. Then my expected values are what we calculate. Okay, now to make this work, you are going to highlight the first cell. You're going to hit Menu, Statistics, and you're going to go to Stat Test. And it already tells us here we want a chi-square goodness of fit. Well, our observed was in column A. Our expected is in column B, and you're going to have to type in these brackets. Our degrees of freedom, 4 minus 1, was 3, and then our result column will be column C. So when we do that, here's our output value using a chi-square test for goodness of fit. We get a test statistic of 45.36. Now our p-value, it's tempting to put 7.75, but remember it's a probability statement, so it can't be more than 1. Well, this yellow highlight here tells me it's about 7.75 to the negative 10th power, which means it's really like 0.000000 blah, 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 7. So it's a really small p-value. Then here we have our degrees of freedom, and here's our contribution list. Well, all of these numbers come to us from our example. We calculated the degrees of freedom to be 3. We added up each contribution, and we got 45.36, so we are as good as the calculator. And then in our p-value here, using the same values, I get approximately 0. So we did it by hand, but you can totally just go to the spreadsheet function to calculate your goodness of fit. So that's how you conduct a goodness of fit example. Now, that's when they are uniformly distributed. Let's take a look here at the claimed example. So this is when it's asking us to follow a claimed distribution. So we're going to exit this again. We're going to do it over. Again, you want a new document, add spreadsheet list. So again, our observed, we're looking at example 3. Color distribution. So our observed data are these numbers here. So in the observed, we've got 13, 27, 6, 8, 27, 19. And our expected, we calculate it based on the claim distribution. And again, so we should have matching numbers because we're observing and expecting per category. So menu, stats, stat test, goodness of fit. Again, observed is in column A. Expected is in column B. Here we add 6 minus 1 gives us 5 degrees of freedom, and our results will be in column C. So we conduct our chi-square test. Here's our test statistic. Here's our p-value, degrees of freedom, and each of the following 6 contributions. And we compare again, and it looks like, look, same thing, same results. So that's how you run a goodness of fit. Now, for homogeneity and independence, it gets a little spicier. So here is now homogeneity, because again, I have multiple groups, and I'm measuring one categorical variable across multiple groups, which is their opinion. So on this one, for homogeneity and independence, instead of doing a spreadsheet, I'm actually going to go to the calculate. Now, in order to do this, I actually have to create the matrix, which is what I am observing. So I'm going to create a matrix here. So you're going to go to Menu, Matrix, and we are going to create a matrix. So again, if I'm looking at this example, I have 1, 2, 3 rows by 1, 2, 3 columns. So I'm going to be working with a 3 by 3 matrix. Now I'm just going to type in the observed numbers. So here I have 266, 266, 186. Then I have 308, 250, 176, 28, 27, 28, 27, and 21. Now I have to store this matrix. So I'm actually going to hit Control Variable, and it's going to give me this little arrow here, and I'm just going to type in a letter. A. So every time I type in the letter A, I should get my stored matrix. So now what happens is to conduct my significance test, I'm going to go Menu, Statistics, a statistics test, because remember we don't have a confidence interval here, and we're going to use a chi-square two-way test. Now notice it says chi-square goodness of fit, but it doesn't tell me homogeneity or independence. That's just because it's looking at a two-way table. The only difference, again, is in the null and alternative hypotheses. Well, here we look, my observed matrix is matrix A, and I get my chi-square statistic of 4.017, a p-value of 0.4037, and a degrees of freedom of 4. And if we look at our results here, we get the same exact thing. Here's our degrees of freedom, here's our p-value, here's our 4.017. Now to get this expected matrix, we're going to go here to the calculator, and notice this EXP, it's given to us here. So you're actually going to hit the variable button, and then I'm just going to select option 4, stat.expectedMatrix, and I hit enter, and this are my expected counts, which I did some rounding to 1 decimal point just because we had 9 of them, but you can see that it's relatively similar to what we'd expect. So as long as you show that it looks roughly the same, you're good to go. So this verifies our conditions for inference. We can see that all expected counts are at least 5. Okay, so the only tricky thing for homogeneity and independence is that you have to just list the matrix in order. This one didn't ask you for a chi-square procedure, it just asked you for the individual contributions, so we'll skip that for now. Let's do an independence example so you can see how similar it is to homogeneity. All right, so we've got a new matrix, and in this matrix we have a 1, 2, 3, 4 by 1, 2. We've got a 4 by 2 matrix, so I'm going to go here into the calculator, and I'm going to create a new matrix. So now we do a matrix, create, and in this matrix, I'm going to we have 4 rows by 2 columns. Hit enter, and we're going to type in our values here. So 24, 20, so 40, 52, 13. Then we come over here, we've got 50, 27, and 30. And again, we're going to store this as a new variable. So I'm going to hit Control, Variable to get this little arrow, and I'm going to give it the letter B. So now to make sure it works, every time I type in the letter B, I should get my new matrix, my observed counts. Okay, so we run a significance test. So we go to Statistics, Significance Testing, and again, notice it doesn't say a chi-square test for independence, just as a two-way test. Select that option. My observed matrix is matrix B. Hit OK here, and I get a test statistic of 15.8306, which let's see. In our values here, we got 15.83. We got 3 degrees of freedom, and the calculator can concur. We have 3 degrees of freedom, and a p-value of about 0.0012. We look here about 0.0012. All right, and next up here was the expected counts. So to obtain those expected counts, I'm going to hit the variable button, and I want the stat expected matrix. And those are the expected counts that I wanted. Now, the only thing you have to be careful on is that when you do the expected matrix command, it's going to do whichever chi-square test was just run. So I would have to rerun the test on the matrix from homogeneity to get this expected matrix again. Because now the variable that's stored is the new matrix that I put in. So as long as you're doing each problem independently, no pun intended, you're good to go. The calculator will remember your statistics results, your significance test results for that expected problem. Okay, so that's a little bit more on the calculator commands. Now for the chi-square CDF to find these values, so for example, in our last example here, you're given a chi-square value of 15.76. So to find that value, you go to Menu, Statistics, Distributions, and you go to a chi-square CDF. The lower bound will be your test statistic, so here 15.76. And because these are always skewed right, you're just going to put a bunch of 9s, and then the degrees of freedom depends on each situation. Here, degrees of freedom was 1, so we hit OK. We get a p-value of about 0.00072. If we go to example 2 from lesson 1, here chi-square test statistic of 18. So again, we go to Menu, Statistics, Distributions, chi-square CDF, lower bound of 18. Upper bound of 99999, and then degrees of freedom was 6, I believe. Yes. We will calculate that and we'll get the same p-value. So once you obtain your test statistic, you can get the p-value by using the distribution command, or you can just use one of the procedures that we learned about. But that's a little bit more help on chi-square inference on the calculator. Hope this helps.